Okay, this is the notes for section 5.2, solving systems using tables, graphs, or a CAS. In this chapter, we're looking at our first way of solving systems in terms of coordinate on our coordinate plane, x, y values or ordered pairs. So in 5.1 we were looking at solving systems involving one variable. So starting in 5.2 now, and really for the rest of the chapter, we're going to be looking at solving systems involving two variables. Now, we're going to look at a lot of different methods of solving systems. You're going to need to know how to solve a system given any one of these methods. Most of them have specific situations that are better for solving systems that way, and we'll talk about that as we move along. Okay? So the first method that we're going to look at is basically using your calculator. How can we use the graphs on your calculator? How can we use tables? And how can we use the solve feature on your calculator? Okay, let's take a look at example 1 here. What we want to do is we want to solve this system graphically. So we're going to use our graphing calculator to do that. In order for us to use our graphing calculator, the first thing that we have to do is we have to take each one of these equations and solve them for y, because in order to enter something on our graphing calculator, remember, it needs to be solved for y or be able to write it in function notation. So if I take my first equation and solve it for y, I'm going to get 6 over x for y, dividing both sides by x. And the second equation, if I bring y over to the right side and bring 5 over to the left side, the negative y would become positive and the 5 would become negative, therefore y would be equal to x minus 5. So now what I'm going to do is I'm going to go to my graphing calculator and I'm going to graph both of those. So I'm going to go here, I'm going to start by doing a new add graphs. Okay. And then for F1, I'm going to enter 6 divided by x. If I hit enter, it will graph that for me. And then I want to go down here and I want to actually enter a second function. And if I click on this, it's going to bring up F2 as well, and then I'm going to input x minus 5 into my grapher, and it will graph that line for me. So now I have both of my equations graphed. Therefore, I'm looking for the solution to that system. Well, graphically, that solution is the intersection of the curve with the line. So, as you can see in this particular example, there are 2 points that would be those intersection points. So I want to find those 2 points. I'm going to go to Menu. So on your calculator, and it doesn't matter really which calculator you use, you're going to go up to Menu, and then you're going to go to Points and Lines, and then you're going to go to Intersection Points. Okay? And then your calculator is waiting for you to tell what you're looking for the intersection of. Well, I want to look at the intersection of the graph of F1 with the graph of F2. And you'll notice when I click that, it brings up the value of those points and plots those points for us. So the solution is 6, 1 and -1, -6. So when I write the solution to that system, then it would be the set of 2 points, 6, 1 and -1, -6. So in the last problem we looked at using graphs to solve functions. The third thing I'd like to take a look at is using the solve feature on your actual CAS calculator. And we can solve it actually using that solve feature in 2 different methods. The first is to enter it kind of like we see it as a system, and the second is by connecting the two equations with the word and, kind of like what we were talking about in section 5.1. So let's look at the first method. So what you want to do is start with your calculator and just open a new calculator screen. So just go to your home key and select a calculator. Then what we're going to do is we're going to go to Menu, Algebra, Solve. So on yours, Menu and then Algebra and then Solve. Now when it does that, it brings up a window that looks like this. Now we're going to enter the system just like we see it. And to do that, we have to use this key on your black calculator, okay, which brings up this menu, and we want a system involving two equations here. So I'm going to input this one right here, and then say hit return, and then I can enter those two systems in here. Now when you do that, make sure that you enter it in such a way that you have y equals and then whatever that value is, same for both of those, okay? And once you do that, then you're going to want to hit your right arrow so you're kind of on the same, on that middle level, and put a comma. And then we're going to put x, y in brackets. So I'm going to come over here to, on the black calculator, it's control and then the brackets here, okay? And then that would be x, comma, y. And that's just telling your calculator, what do you want me to solve this for? Okay? And then we'll put our end parentheses on there. Okay? And then once I do that, I'm just going to hit enter, and it will give me the solution to that system. Okay? So what that tells me is that the ordered pair -2/3, -7/3 is the solution to that system. So when I write that system, I'm going to write it like this: -2/3, -7/3. Okay, then the second method that we can use using our CAS calculator, and I'm going to solve the same system here, is to enter it with an AND in between the two equations. And once again, you're going to put a comma and then the x, y in brackets. So on your calculator, you'd want to do that. Okay. And here's how you would do that. So solve, and then in parentheses, here's the first equation, and the word and you can type that in your calculator. Or if you want, you can go to the library key on your calculator, which is this little book here, and select and there, and you can just, if you start typing in A, it should come up. That's another way that you can enter it, but sometimes it's just plain easier if you just type it. So once you do that, and then you can go ahead and hit return, and it will give you, notice how it's the exact same solution. So both these methods work using your CAS. Okay, at this time then I'd like you to just pause the video, and I'd like you to solve the system for number 2. I'd like you to use your CAS, make sure that you're able to do it, and you can use it in either one of those two methods. Find the solution, then go ahead and turn the video back on, and I'll have the answer for you. Okay, so the solution you should have found was -6, -16. Now you can remember there's more than one way that you can enter those, but I entered it like a regular system here, okay, for x, y, and notice how I get the solution: -6, -16. Okay, let's take a look at the final example here. It says Fred wants to enclose a 400 square meter rectangular garden with 70 meters of fencing. To do this, he must use one side of his barn as a side of the garden. What can the dimensions of the garden be? Okay, well, first of all, we're going to draw a picture of that. So we've got the barn here. I've got the width and the length of the garden, and so that one side is enclosed. So this stuff here, this is my fencing here. All of this stuff would be fencing. Okay, so I can say, well, the length times the width I know has got to be 400 because it says it's a 400 square meter rectangular garden. And I know that the amount of fencing that I have a total of 70 meters, and to get it, it's this perimeter minus this side. So it's width plus length plus width, or 2 times the width plus the length has to be equal to 70. Okay. Well, there's a couple ways that we can solve that. Number one, we can solve it graphically. Okay. solving them for L and then go ahead and graph those two functions, or I can solve it using the solve function. At this time I'd like you to pause the video and do that on your calculator, and then I'm going to go over the answer here in just a second. So graphically, if I graph those two, I should come up with a picture that looks something like this. Now, you may have found that when you did it graphically you didn't see anything, but remember you have to change your Windows settings, and the easiest way I find to do that is to go to Window and go with a zoom in or zoom out, okay, depending on what you need to do. So what I would do is I would do that right on the center at 0, 0 until you see the graphs. Once you see them, then you can find what you're looking for. So once I've done that, I'm left with these 2 points. So I looked at the intersection of the two graphs, and these would be the 2 points. So somewhere around 7 and 56, and also the point 28 and 14. Okay, so that would be my solution there. So when I write that solution out, I can write it like this, either 7 by 56 or 28 by 14.